Hello, I'm David Baker of Origin Live, and this is my dad and company founder, Mark. And today what are we going to be talking about today?
We're going to be talking about a new product called the Ground Anchor, which has been designed and manufactured for us by Puritan Audio. And the Ground Anchor is an interesting product and not an easy one to understand. So we're going to try and go there because it answers a problem that many people just simply aren't aware of, and that is the ground noise that's coming through your mains. Mm-hmm. And this ground noise affects every transistor, every component in your circuits of your audio equipment.
So what is the ground?
Well, good question. If we talk about the ground, most people, in electronic circuits, you basically got what you think is 0 volts, which is the ground. That's the signal for ground, so 0 volts in theory. And everything in your electronics is referenced to this as a kind of rock solid base, and that's where you start with your design. And if this isn't rock solid, you're in la la land basically, because nothing, you got no reference.
So we'd have a positive rail.
Yeah, you got positive, sometimes you got negative as well, but
everything references.
Yes.
This.
So every signal is kind of referenced to this, and that's how your signals are determined. Now the problem is that you've got a signal coming in here, all right, and that is then controlled by your transistor, and it's usually amplified or regulated, whatever the case may be, and it comes out as a bigger signal. Now this is referenced to 0 volts here, and the problem is that it's just, the assumption is that is absolutely rock solid, but it isn't, because what you've got is contamination on your ground, and we're going to talk about how that gets contaminated. But if you can imagine, you've got all sorts of frequencies on your ground. You've got low frequencies, which is usually residual mains, 50 hertz or 60 hertz if you're in America.
So that's noise from the mains.
Yeah, it manifests itself as noise because there's a device called a rectifier which is supposed to smooth that so it's 0, but the fact is that you get contamination entering the ground through the smoothing operation, and so you do get a little bit of ripple on the mains. It's there. More seriously, you get a lot of pickup from routers, switch mode power supplies and everything else, which is kicking back stuff into your mains plugs, and we'll discuss all this later. But first of all, just to establish that this is what is on your mains. So you've got low frequency 50 hertz, and then you've got high frequencies which start at about 100 kilohertz. That's a low switch mode power supply, and then you go right up to 5 gigahertz now, I think it is, isn't it? 5 gigahertz, which is incredibly high frequencies. And that's getting on, and that's so spiky. So you get all these aberrations which are present on your ground, and your circuits are having to relate to this. Not only that, but even on the signal, okay, so your signal comes through a wire, like your tonearm wires or something like that. If your signal happens to pick up the Wi-Fi or whatever else it might pick up.
So all of that kind of stuff that's actually floating around us all the time.
Yeah.
RF, Wi-Fi, electromagnetic interference.
Yeah, everything. It finds its way. It's all pervasive, unfortunately. So if that finds its way into your signal, it sets off something which is what we call parasitic capacitance in your transistors, which is a little charge that builds up at high frequencies across every transistor joint. So you've got maybe hundreds, thousands of transistors in your circuit, and your IC chips in particular, they can have hundreds and thousands of these things. And you get little build-up of parasitic capacitance across these. And that, I love the word parasitic because it's a nasty word, and this is a very nasty effect. Capacitance on the transistors basically means that this point is charging up and discharging randomly. And that is not good for the purity of your output signal at all. In fact, it results in harshness in electronics. I suppose the main thing you'd hear it is there's a harshness in the sound. It can cause muddiness. Cloudiness, it just messes the signal up. It's something which the ear knows shouldn't be there, and it's
So
nasty.
that's
In fact,
really
this is so obvious that I was having a chat with Mike of Puritan, and we were saying, did HiFi used to sound better when we started off, or is it that the mains is now so contaminated that everything's turned to mush, And we were concluding, yes, on the very high end stuff, there is definitely an improvement. But we both remember quite low end audio sounding utterly fantastic. And I think a lot of it is when you listen to low end audio now, and it's awful, it's garbage, most of it. And a lot of this could be down to this effect, that everything's contaminated.
So do you think, back in the day, things sounded kind of richer and more?
Oh, undoubtedly, yeah.
Because there was less interference.
Yeah.
And how does that kind of manifest itself now?
I mean, everything has to be built to a budget, and there's only so much that you can do to guard against this sort of stuff on an amplifier. But it's not just the audio equipment that's the problem, because something like when we look at the sources of contamination, you've got your Wi-Fi routers.
So that's the 5 gigahertz.
Yeah, they're emitting very high frequency.
100K to 5 gig. Okay.
Yeah, and then you've got things like your switch mode power supplies, and switch mode power supplies are a biggie because although they're not emitting an airborne wave, they do feed contamination back into the mains. And the only protection that a lot of them have is that if that's your positive and negative, say, for a charger, this is a car charger, by the way, sorry, then you've got your earth down here. And to save these, putting out contamination to, because there's regulations now about how much things are allowed to emit and so on. What they do is they simply put a capacitor across here and dump the noise into the earth, into the ground. So any noise that they're generating upstream here in the actual charger, any noise will feed back due to back EMF, and it's then dumped into your ground.
And
so
then
that's
the whole of the audio signal has to reference that
ground. And it stays in the ground for a very, very long distance. These waves travel completely around your house. So if you've got a contamination one plug socket, it's going to come out of every plug socket in your house.
Okay, so this is really interesting. So all of this is really high frequency, and obviously we know that most audio is 20 hertz to 25 hertz. Sorry, 20,000 hertz.
To 20 kilohertz. Yeah, if you're a young child, if you're my age, it's more like 4 to 15 kilohertz.
That's very humble of you. But the problem is that even though this type of noise isn't necessarily within the audible spectrum, it's building up capacitance in our transistors.
Yeah, you can't hear this. It doesn't actually come out directly because you can't. The audio frequency is only.
We can't hear these frequency bands, but they are actually affecting the transistors in our audio electronics.
Yeah.
That's so interesting. And that presents itself as interference with the signal or distortion in the signal?
Both. I'm going to get a little bit complicated here now, because you think, well, if you can't actually hear this because the waveform it's introducing is inaudible because it's at such a high frequency, and your speakers certainly aren't reproducing it either.
Yep.
But what happens with intermodulation distortion is that if you've got a waveform here, all right, and you superimpose another waveform on top of it, I'm not going to be able to draw this very well, but say you've got another waveform which is doing this.
And would this be our kind of...
This is your high frequency contamination, all right? This is terribly unrepresentative, so please don't take me to task for it, because I'm not going to be able to draw the interference pattern very well, but it's going to cause it's going to distort the shape of the wave because that wave is superimposed on that. You're going to get these sort of effects. Instead of being that's what the wave should look like, it's going to be distorted. Now, of course, the sound wave is all over the place. The sound waves are doing it. This is just drawn for representative purposes or to show how you get that interference.
So we've got intermodulation distortion from actual mains noise at around 50 hertz.
Yeah.
But then we also have some level of distortion from the upper frequencies.
Yeah,
100 to 5 gig.
You probably, 100 kilohertz would definitely give you some intermodulation, but when you get up to the very high frequencies, it's all about parasitic contamination.
Right.
Yeah.
So what's the kind of solution to these things?
Well, there's a couple of little tips which may or may not be helpful, because when it comes...
Let's take a short wiping break. Hi, I'm quickly interrupting this video just to ask that if you're finding it worthwhile, please could you hit the like button, subscribe to the channel, and also press the bell notification. It really helps us to carry on making these videos. And yeah, what we want to do is carry on having open conversations about vinyl replay and also giving you insights into how we've been making turntables and tone arms in-house in the UK since 1986. Well, not me personally, because I'm 31, and that's... Anyway, you get the idea. So thanks, and back to the video. So what are the kind of solutions to these problems?
Yeah, the solutions are not tricky, is the answer. A couple of tips though. Let's just talk about airborne contamination to start with. Airborne contamination can get directly into your system because it's picked up by wires. So, right, if you have your Wi-Fi router positioned here, say, and you've got a wall running close by here, that wall has probably got mains cables running inside it, just behind the skirting board. Your Wi-Fi router is emitting waves like so. Now, as you can imagine, the closer you are to the router, the more influence that wave's going to have, because there's a much higher density, electromagnetic density here than out here. And that goes down by the square. So it's significant. Even 6 inches off can make a big difference.
Wow.
But, you know, distance is all about distance. So you want to try and position your router a little bit off from the wall, because otherwise your mains cables are going to pick it up. They're like an aerial. Basically wires, cables, mains cables, everything that you put into your equipment, loudspeaker cables, they're like aerials for this stuff. It's not only your router you're worrying about, it's also, you can't do anything about it, but you've also got radio waves,
right,
which is what you tune on your car radio. They're pervasive everywhere. So once this high frequency gets into your mains, it just goes throughout your house and there's no escape. Try and kill it at source by just positioning your router a little bit away from everything.
So mains is already super noisy, as I think most audiophiles know. Maybe your kind of layman doesn't necessarily know, but mains is super noisy, but this is injecting more noise around the 100 kilohertz to 5 gigahertz level.
Yeah.
Wow.
And I mean, obviously, if you've got a plug socket here, say, and you've got dozens of cables in this area, they're all going to pick up the RF in high density. Bad news. So first of all, be careful where you position your router.
Can this affect our audio electronics as well?
Yeah, absolutely.
So our amplifiers, our phono stages, this
Everything.
kind of stuff.
Yeah.
So we just want to put this out of the way of our audio electronics.
Yeah.
And our mains cables. Okay.
Yeah.
I'm with
because
you.
if you imagine that you got your high frequency, once your high frequency is on your mains, everything connected to your mains is injected with high frequency, because almost all electronics equipment is referenced to the earth. Now, various manufacturers do have all sorts of devices. It's like warfare against noise. You know, they do have these anti-noise measures, but it varies with the equipment. And it's interesting talking to a distributor of vast experience in Germany. He said he'd tried a lot of noise reduction devices, and he says they're notoriously erratic. Sometimes they're fantastic, and other times they don't seem to work at all. And there's reasons for that. Some of it is the equipment.
Some kind of system matching with different stuff.
Yeah, we found that we recently changed our speaker cables to some very high-end speaker cables, which were given to us as a gift by a fantastic loud
Audience
speaker.
AV.
Audience AV, who were so impressed by our tone arm that they gave us a pair of these cables as a present. And they are fantastic, absolutely fantastic.
I wouldn't have considered myself a cable denier, but it was. I was pretty stunned. I wasn't expecting that difference from them at all. But.
Yeah, well, most people don't have them, but we found that these cables did a huge amount to reduce ground noise.
Really?
Yeah, because your cables, your loudspeaker cables, are attached to the ground of your amplifier.
Right, of course.
And if they're picking up a lot of RF, then you see, this is where we don't know whether it is that they're not picking up RF so well, they're not shielded, are they? Or it's that they're actually absorbing the RF somehow. Anyway, I don't want to get too speculative on that, but it is interesting that different systems have hugely different responses to grounding effects.
Yeah.
Radio hams, going back to when this all started, I mean, we've always had contamination on the ground, but it's just 100 times worse nowadays than it ever was. When I first started HiFi, radio hams were well aware of the problems of, noise on the ground. And what they would do is they'd get a bit of copper pipe, go into their back garden, hammer it into the ground, attach a wire and attach it to the ground of there. But that is illegal now because it interrupts the tripping mechanism. And so it's unsafe. It's an unsafe practice. Now, again, there are products like Puritan Audio produce a very good one.
It's a ground spike that you put into the earth outside your house.
Yeah, but you have to then put it through this device, which makes it safe.
Right, so it's not connected to your house mains, an external.
No.
Okay.
But they have two types. One which you don't need to have a grounding.
It's the Groundmaster City.
Yeah.
We actually used that at Bristol. Mike just wandered up to our room and gave us one.
Yeah.
And said, plug this in, and it was actually really good.
Yeah. So there are an increasing number of grounding products on the market that basically they try and mimic. I mean, the ground is the ultimate thing. The copper pipe in your garden lawn is the ultimate.
Elite level. Okay.
Yeah, that really does work. But even everything you do, it's better if the problem isn't there in the first place. Yeah. Everything you do is only to kind of try and reduce it. Mains contamination is just bad news, and it's always going to be, there's a residual always going to be there. Some people go to the extent of actually trying to recreate the mains wave itself, so you get these generators. Artificial generators.
Well, I mean, I think one of the answers to mains is actually playing vinyl, because it's a generator. It's creating brand new electricity at source. So the actual source creation is far less affected by mains than something like digital.
Oh yeah, absolutely. It is an interesting one, that, and the fact that your cartridge is completely isolated from any mains interference, and it's generating its own electricity is one of the reasons for the purity of signal that it can produce. Obviously, it's got to be amplified by electronics later on. But the source, for the source to be pure in the first place is a huge advantage. Yeah.
Even the vinyl signal, like we were talking about earlier, the tonearm cable and the tonearm itself is subject to some level of airborne interference, right?
Yeah.
So that can act as an antenna.
Oh, absolutely. Even if you have...
our cables, we've got a tonearm cable here, so this is just a long line that's picking up any kind of RF and DMI and...
I mean, I used to experiment with... I don't like shielding for other reasons, but I have to use it. We have to use it.
Yeah.
But I would sometimes just leave... We tried to leave 4 inches of this cable unshielded because it's more flexible.
Right, okay.
Okay, big advantage. 4 inches, I could pick up a radio station on that, playing through the speakers.
You're getting wave 105.
Yeah, so, yeah.
Were you seriously hearing?
Yeah, you could hear the radio station, yeah.
Wow.
But the signal coming out of a tonearm is 1,000 times less than what's coming out of your CD player or your streamer.
Yeah.
So any interference on that signal will have 1,000 times more influence than if it's on your streamer or CD. So we have to shield these cables. We actually ground the shield, which is, just to explain this cable, we really do go to town. Yeah, what we've found, and this is an area which is too complex to explain really, but because of the different designs of phono stages and preamps, some use floating earths, some don't, some treat the earth in a different way, that we found that it's best to provide options, and the end user can basically just experiment with these options and find out what works for him.
Yeah, I generally find that all 3 Blues have the lowest amount of hum, like audible hum, when we're connected.
Yeah, let's explain what they are. Let's explain what they are to people first. So the blue earth on the cables is actually earthing the shield that goes down the cable. We've got 2 blue earths there. The black is actually attached to the cold signal. Now, Riga use this. They earth the cold signal, or the cold signal from the cartridge directly to the earth.
Okay.
It's just connected there. So that's that option. You can connect the cold signal to the earth. And this long wire actually connects the structure of the arm to the earth, because the structure of the arm will also pick up.
Yeah, because that's a metal tube.
Yeah.
Yeah.
So on the ground anchor itself, we've got 3 terminals, which just make it easier to put all these wires together, because if you try and piggyback them together, it gets a bit awkward. It's possible.
It's kind of fiddly, yeah.
It's possible, but it just is fiddly, yeah. So you can experiment and try the various wires, okay? And then, so the ground anchor simply goes between your earth wires, not your signal wires, just your earth wires, and that goes onto your amplifier. And it soaks up nasties, basically. We were stunned at the effects because, I mean, I did play around initially with different types of wire. I tried screening the earth wire, thinking, oh, that might make a difference. It didn't work at all.
It's already noisy.
What does the screen attach to? So this really is a fantastic answer, and it's worth trying because we've had people who are really, really impressed by what this does. It's half the price of the first. I mean, the first of these devices on the market was by Chord Electronics, wasn't it?
Well, there's quite a few actually. There's stuff by Trek, Shinyata. There's a lot of things out there.
Yeah, but do they do the? I don't think
yeah.
they're specifically designed for tone arms yet, are they? They mainly just earth of your equipment.
That's right. I think the Chord
Array
is probably the first
Chord
one
of
I've
the
seen
first.
specifically for tone arms.
Chord were the first, and that device was 1,000. This is
545.
Is it?
Yeah.
Right. Okay.
Well, you're surprised. That's good.
I just thought we'd probably try and keep it below the 500 mark. But,
Price is now rising.
Yeah, but there's a lot in this device. There's not just a capacitor in there or something. There's a lot in that device, and it's complex. And Mike has been in this game all his life. He's one of the world's experts, I'd say, for what he does. I mean, when it comes to things like mains regenerators, there's a huge debate as to whether they're actually better than the mains filters that Mike from Puritan provide. But I know from end users who have tried both that they've always ended up with mics.
Yeah, people seem
and
to
he's
love
outperforming,
Puritan, yeah.
and he's outperforming stuff at over 5 times the price.
Shout out
People-
Big Mike Lester.
People think that, if I'm buying a really expensive mains purifier, then it's got to be up to the job. It doesn't necessarily mean it's better than one at a lower price.
Yeah. I mean, interestingly, I was talking to Mike about that, and Mike said this might cause a bit of controversy, but there are devices that perform really well according to measurements, but Mike is kind of like us in that everything has to pass a listening test.
Yeah.
And he will develop stuff by ear, he will develop stuff
Yeah.
by listening, and if it doesn't sound right, it doesn't go out, which, we're exactly the same. There's
Yeah.
almost too much time in development because things have to sound right.
Yeah. And I think going back to Mike's design, it's interesting talking to Mike. He knows what all his competitors use in their grounding products. He knows, he was telling me what they all use. Right? But when I ask him what does he use, he's absolutely a clam.
Yeah.
He says it's like a series of sponges which
He
soak
said
up the...
noise soak, which is tight-lipped.
Yeah, but they're all very confidential. All of
Yeah,
the
you can't blame
grounding
them.
device people are very tight-lipped about what they use. And
Yeah.
it's because it takes an awful lot of research. You would not believe the amount of research that goes into this kind of stuff.
Yeah. Well, I mean, I can because we do it, but I
Yeah.
think most people, don't necessarily know about the countless hours that go into having something that, isn't quite right, and getting it across
Yeah.
the line takes so much time.
Yeah, and I think that's one of the reasons that he wouldn't outsource this to, the Far East, because he would be having to basically give away his trade secrets. So, and you can't find out what's in there by putting a bandsaw through it either.
Yeah.
Not that we've done that.
Yeah.
I wouldn't do that,
I
but,
think that's another thing that was why we wanted to work with Mike as well, is because he makes everything in-house in the UK.
Yeah.
It's, it's a
Yeah.
UK manufacturer.
Yeah. I mean, if it wasn't, the price would probably drop massively because anything
True.
made in the Far East that's what happens. But you do have quality issues sometimes.
So this product is for all of the kind of noise that your tone arm is going to pick up, some from the mains, some from RF, electromagnetic interference, and Wi-Fi.
Yeah, power supplies are a biggie. Yeah, I mean, when I first became aware of the problems with switch mode power supplies, it was a big surprise to me because basically we had a motor kit that we'd been producing for years and everyone was very happy with it. And then all of a sudden we started getting 5% of customers saying that they were having problems with it. And they'd send them back and we'd find that the chips had burned out.
Right.
And we couldn't figure out why this was happening. And it was intermittent, it was only 5%. So in the end, after 3 months of trying to solve the problem and failing, I took it to a friend of mine who's a professor at Southampton University, lectured on electronics, was a consultant for Boeing, designed for them, top of his field. And he put it on his test bench and said, can't see anything wrong with your design, Mark, but we'll keep an eye on it for the next few days and see if anything happens. And sure enough, about 9 hours later, it kicked off. And from producing a lot of contaminated, waveform, which it shouldn't have done because it was a regulator, a voltage regulator. So he was wondering what on earth had kicked this off, and he tracked it down eventually to a bathroom switch mode fluorescent light that he had recently installed.
No.
Yeah, and he found every time he switched this on, sure enough, the thing went mad, started going into oscillation, and as soon as he switched it off, it stopped. So that was my first introduction to problems of switch mode power supplies. And once we knew the problem, we were able to deal with it by toning down what I was using a very high-end integrated circuit chip at that point in time. And he said, well, the solution is just to downgrade it so it can't possibly respond to all this high frequency stuff you're giving it, And that was the fix. But it just shows how these devices inject horrific stuff into the mains. So anyway, I think that probably winds up everything we need to say at the moment.
So this is one solution. This is our ground anchor that is now live for purchase. Obviously there are other solutions like mains filters out there and kind of the grounding spikes.
Mains filters are fantastic. We use the Puritan audio mains filter.
Okay, cool.
Okay.
Well, thank you so much for your time and your wisdom on that.
It's always a pleasure.
Yeah, we see each other every day. Okay, thank you so much for watching. I hope you've enjoyed that. There's more to come. If you have any questions on this or any other subjects, please drop them in the comments below on this video. Thank you very much for watching. Okay, that was good.